Hello everybody and welcome to the DailyME episode 6. In today's video, we got to turn this into a jig. Let's get going. And so in yesterday's video, I got gluing all of these ferrules and knife holders together, and I chamfered the ends as well. And the next job will be drilling what will be the grub screw hole and thread. Now the problem with this is that you can't just expect the drill to be able to go in straight into that rounded surface. I found in past experiments, no matter if I used the mill, the drill press, that drill bit would slip either side and I wouldn't get an accurate hole. Not to mention the fact the hole needs to be at a perfect 90 degrees to the blade slot in order to be effective. And so this is the jig I came up with to solve that problem. But before I show you how this works, I'd like to thank today's video sponsor. So firstly, let me show you the problem we're trying to solve here. So most of our wallets probably look like this, stuffed with things that we don't even know we had. Oh, here we go, here's one. Too much rubbish in day-to-day life. You should only be carrying the stuff that you need. And this is where the Ridge wallet comes in. And so you know what it's like when you're searching through your old wallet and you're trying to find that, literally with the Ridge wallet, it is there waiting for you. And of course, if you're not one for carrying cards, simply shove that in there and you've got the optional cash strap on the back. And the cool thing about this is it comes in a whole host of different colors and materials to suit different tastes. I've personally opted for the titanium matte black because it just looks awesome. But if you would prefer, you can also get it in carbon fiber, aluminium, titanium in a range of different colors. And as for the overall build quality of this thing, it's got a wonderful tactile feel. It's durable, and above all, it looks sleek. And so if you want to join me in the 21st century with less of this sweaty stuff handed over to one another and better security, because this material's RFID blocking, by the way, you can use the link in the description below, ridge.com/Estlea, where you can claim your 10% discount using the coupon code listed below. And so thank you very much to Ridge for sponsoring today's video. Let's get back to it. And I know you engineers out there are going to slate me for this rather rudimentary approach to this, but this is the way the jig works. So firstly, what you do is you get a thin piece of metal and you put that into the blade slots. And this piece of metal is the same thickness as the blades, 0.7 mil or so. And so that is now slotted in there exactly as a knife would be. You then pop that into here, which has a cutout, which was 0.7 mil when I first cut it, but it has since eroded away to be quite significantly bigger. But anyway, that slots in there, and that now holds the blade holder at 90 degrees to the top edge. And you simply slot this part of the jig over that, and that conveniently places this bushing hole in the exact place above the blade holder that you need to drill. And then all I do with that is push it against the back fence, hold the blade holder in place while also pushing this end, and then you just drill it in with a depth stop like that. Occasionally the bushing here falls out, but it actually helps with clearing the chips. So I want to say it's not an issue. It is quite annoying, but there we go. The funny thing about this though, as ropey as it looks, after 100 knives plus about 20 prototypes, it still works absolutely fine. This knife was made using this jig. I just don't really have much faith in it holding out for the next batch, seeing as this is much bigger. And so that is where this big old block of metal comes in, because we want to make a new jig and I want to make some like bronze bushing or something just to make sure that the wear resistance of it is really high, and we need to get designing it. And so for the next jig I make, the only real criteria I want to change is the material, which we've already discussed, to make it a little bit more durable, and I want to make it out of one piece. I don't really like having these two separate things that need to slot together because I think it just slows down the process, and it's probably more accurate having it as one solid block. And so I've got an idea in my head of how I want it to work, but the reason I'm showing you this process is so you can suggest better ideas, because this stuff is completely new to me. I know there's engineers out there, so please, if you have any suggestions, chuck them on the forums on my website. I'll put a link to that in the description and it would be really helpful, really helpful. So let's get drawing this. And so this is it. Perfectly achievable on the milling machine. It's simply a right angle cutout of one side of the bar and doesn't involve me drilling any square holes, which I had no idea how I was going to do. And so in theory, I guess it would kind of look like this. So the blade would slot through from the back like that, and there would already be a platform here for that piece of metal to rest on, and then that would hold it at 90 degrees. The other thing I forgot to mention about this metal is it's very crucial in holding it at 90 degrees, obviously, but The other thing is it prevents getting too much breakout on the inside of the slot when I glue and tap it. So it is absolutely crucial I have a piece of removable sacrificial bit of metal there that I can replace after every couple of drills. And so I think that's enough talking for now. At the moment, this bar is a little bit too long, so I need to cut that off, and then I need to find a way of squaring it up, although I don't have any parallels for my milling machine, so I think I might struggle to do that. It might be square enough though, so I'll probably just try and make it while you're leaving this bar rough and see what happens. And if it doesn't work, perhaps I'll look at some of your redesigns and see what you come up with. This ain't gonna happen, is it? I don't know what I'm doing. Oh! So this is not time wasted. Oh, that's kind of right in.
If it works, it works. Wait.
Right, well, we got about halfway through the bit of metal and I don't know what happened. It just started smoking and steaming when I was putting on the coolant. I think I might have accidentally worked hardened the inside of the metal, perhaps. I don't really know, but either way, it stopped cutting, the machine started stalling, which is really annoying because we were making such good progress. And so I think we might have to call this method quits, unfortunately. Okay, so for the sake of getting something done today, I think what we're going to do is try and make that exact same jig, but out of this. Lignum vitae. Rob just reminded me that I may have some stocks of it. I had a look, I found some, and this is actually pretty good in terms of dimensions, and we should be able to make that jig and at least test the theory if it works. We might find that that right angle, after all that, may not have worked, and so actually doing it out of this might be a more sensible option. And then in the meantime, we'll wait to hear from your designs and then see what actual jigs we can make for this to last long term. Now, we need to create the step. Okay, so we've got the new wooden version in the clamps, and I'm just letting a little brass plate dry in the top, and I've used Araldite Rapid to fix that in place. And so the reason I've put this brass plate in here is to give the bronze bushing a more substantial, more secure area to be locked into afterwards. The problem with this original design is that the wood surrounding the bushing just compressed and it ended up making this thing loose, and in time that won't be very accurate. It's quite wobbly, but it's still kind of accurate at the moment, but I'd rather have something like this with metal surrounding it that doesn't allow it to move. And then by having that big brass plate in there with this extra gluing surface either side of it should mean that that brass plate isn't going to move either. The other thing that I think was wrong with this initial design was not necessarily with the design itself, but how it was used. You can see the amount of chippings and stuff that have been embedded in this on all the faces and how greasy and oily it's got. And that's because when I was using this, I was putting it in, drilling it, pulling it out, all the swarf would fall onto the table and then it would just get embedded in it in subsequent passes and start degrading the jig. And so with this one, what I'm thinking is I might instead mount it higher in a engineer's vise, drill it on the milling machine to start with, and not allow this thing to move whatsoever. That's the advantage of making this out of one piece as well, in that there is no moving parts to it. And so what I'll be able to do is mount this perfectly under the drill bit in the milling machine, plunge in, bring it out, take the piece out and then slot the next one in without moving this whatsoever, without any swarf cutting into it, and it should make for a much longer lasting jig. And so while the arrol die is drying on that jig, I'm going to machine this down to a 10mm outside diameter and then drill a 4.2mm hole in the center, which is the size of the drill bit we're going to use before tapping. All right, so the first iteration of the jig is together, and I'll tell you what, I think this is going to work. I've just got to peel a little bit more material away from this bottom section here to ensure that the knife holder doesn't fit too tight in there. I'll show you why. So you can see it's sliding in beautifully, and it just hits the top of that section there. But the trouble is it's just slightly too high, meaning that it's actually wedging that blade holder in there. So if I lower that down and get it so it's the perfect halfway point across the width of this, then I should get a really nice lock from it, but it should be easy to get in and out as well. But that is pretty damn good, I would say. Right, I think this setup I've got here is going to work. It looks great. So with this, all you got to do is put the old shim in there, get it locked in, slides in from the back, and then it literally just sits flat on the platform there. And that is pretty secure. And what I realized with this is I can actually dictate how tight that is by simply tightening up this vise slightly, and it squishes the wood and makes it a tighter fit. But that is like absolutely perfect at the moment. And there is no rotating that whatsoever. There's no accidentally pulling it out. And I can get this vise fixed in this position, zeroed on the digital readout, and then we just do the drilling from there. Absolutely brilliant. That involves also no movement of the jig whatsoever. This was the problem with the jig before. Because it consisted of two parts, it couldn't be clamped in the vise like this because I needed to remove that other section. But now this is all one, it can just stay there. Brilliant. And so despite a rocky start on the old milling machine at the start of the day, I pretty much lost hope by that point, we have actually come out with a really, really good result. And if this works well, then I will probably send off a proper drawing of this to the engineering firm and get them to make me a proper jig for it. But I have no doubt this will definitely outlast this batch and any batches afterwards. So very good result. Really happy with it today. So tomorrow we're going to get drilling these out, hopefully get them all done, and then perhaps start tapping them as well. As always, thank you very much for watching. If you enjoyed the video, please do not forget to press the like button. No! Subscribe if you haven't already. Damn it! Subscribe if you haven't already, and don't forget that there is that 10% off for the Ridge wallet in the description. Go and make the most of it. It is a great product. See you in the next video.